Okay, so in this video, we're going to do some more problems regarding calculating the pH or pOH given certain concentrations within a solution. So this problem, first one, says, calculate the pH of a solution whose hydronium ion concentration is 1 times 10 to the negative 7 molar. Now, you can do this many ways, but one of the ways is you can use the formula pH equals negative log of the hydronium concentration, which is H plus. Now, in this problem, it wants you to find pH, and it gives you the hydronium concentration. So you're all set. All you have to do is plug in this number here. Now, if you solve this equation, given this, put 10 raised to the negative 7 in, you will get 7. Now, you don't have to use your calculator for this because it's 10 raised to something, and it's log base 10. So you can simply solve for 7, or you can use your calculator if you're allowed to. Now, another way to do this problem is to use intuition. Just to plainly look at it, like as you guys know, 7 is a neutral solution. So this solution is neutral. Now, in a neutral solution, the OH concentration is equal to the hydronium concentration. And also, the universal constant for solutions are 10 raised to negative 14, and it's that 10 raised to negative 14 equals OH, the OH concentration, multiplied by the H plus concentration. So, given this, and given H plus is 10 raised to the negative 7, if you solve, you find that OH is also equal to 10 raised to negative 7, and these two are equal, and therefore it's a neutral solution. Because when they are equal, it's neutral, and therefore the answer has to be 7, which is neutral for pH and both pOH, both scales. Now, the next problem, it says, calculate the hydronium ion concentration in a solution with pH of 3.36. Hydronium ion concentration, pH. So this is the same as the other problem here, just that it gives you the pH this time. So you have the formula pH equals negative log. I'm going to write the base 10 this time. Usually, like in logarithms, when they don't write anything, it's assumed base 10. Just like in square root, they don't write a 2 there, it's square root. And H plus. But the reason I'm writing the 10 is because in this problem it's useful. You'll see why in a second. So it gives you pH, so let's plug in pH. 3.36 equals negative log base 10 of the H plus concentration. Now, if you guys worked with logarithms, you know that if you have log base b of a equals x, that means that b raised to x equals a. Now you have 10 here, and that's b, and you have a, and you have x, which is 3.36. You want to find a, so you gotta do is b, which is 10, raised to 3.33, but you have a negative sign here. You gotta watch that. So what you can do to get rid of the negative sign is just transfer it over here by multiplying both sides by negative 1 times negative 1, and then you can get negative 3.36. That negative makes this a plus, and it equals plus, which is positive log base 10 of the H plus concentration. Now all you gotta do is use your knowledge about logarithms here, and use your knowledge about logarithms to just plug in. So you got 10 raised to the negative 3.36 equals H plus concentration, and this is equal to, if you solve this equation, you get 4.365 times 10 raised to the negative 4. 4.365 times 10 raised to the negative 4. Yeah, so if you plug it into your calculator, then you'll get that answer. But you notice that in the problem it gives you 3 significant figures. So that's why you have to have your answer with 3. So that equals 4 equals let me write, how would I write this? I'll write it up here. Equals 4.37 times 10 to the negative 4 power. This is your final answer right here. 4.37. So, let's go down to the next problem. Calculate the hydroxide ion concentration in a solution with pH of 6.97. Now this problem is similar to the a little similar to the problem we had in the last video, where it asks for hydroxide, but it gives you pH. So let's just first write our equations. So we have pH equals negative log of the H plus concentration. And then we have pOH equals negative log of the OH minus. So it's asking us for the hydroxide ion concentration. So they want this right here. That's what they want. But they give you this. So what can you do? Now you have to recall that pH plus pOH plus pOH equals 14, because I explained a little in the earlier video that this is a true statement. pH plus pOH equals 14. Now, if you subtract pH from both sides, so you subtract pH, both sides, subtract pH, you can get that. Let's draw a line here. That pOH equals 14 minus 6.97. pH equals 6.97, which is actually 7.03. This is the pOH. So now you have pOH, and you have this formula, and you want to find this. So you can plug this in here, and you have 7.03 equals the negative log of the OH concentration, OH minus. So now we can do what we did earlier here, multiply by negative 1, and then do 10 raised to whatever you got there, here. So you have 10, invisibly wrote in here, and negative. So we're going to make this negative a positive, and make this a negative by multiplying by negative 1. And then you have 10 raised to negative 7.03 equals the hydroxide concentration. Now this you have to plug into your calculator, and if you plug it into your calculator, you should get an answer of 9.33 times 10 raised to the negative 8. Okay.